Hello, c'est Jean-Marc from MilliBox, and today we are talking about MBX32E. MBX32E is our newest sub-THz 3D OTA testing system. MBX32E is made from the collaboration between MilliBox and Aravant, where MilliBox is providing the chamber and the positioner, whereas Aravant is providing the frequency extenders, which are critical for this application. The main challenge when you're doing 3D OTA in sub-THz frequencies is that having flexible wiring coming from out of the chamber to the positioner is barely practical. The solution at those frequencies, we're talking about 1 millimeter coax cables. They have loss. They are not very good in stability over torsion, and they're extremely expensive too and fragile. So this makes it impractical, and the solution is, as the frequency extenders are getting smaller and smaller, we can now integrate them directly on the deck of our positioners, right? So instead of just having the DUT or the antenna array on the positioner and feeding the RF, just the RF cable directly to this system, here we are going to mount the extender right on the deck behind the DUT, where we can make a connection between the extender and the DUT as a waveguide connection. And then from the extender to the VNA, we're going to go with SMA cable. But in that case, we'll have more cables. We'll have LO, measurement, RF, ref, and power supply. So we'll have more cables to run through, and we are going to go through that. But on the other hand, we don't have to run such high frequencies on a flexible coax. When we are talking about sub-THz, what we mean is, if we're talking about waveguide standard sizes, we're talking from WR15. We started at 50 gigahertz, and we go to WR3 at 330 gigahertz. Basically, you have WR15, WR12, WR10, WR8, WR6, WR5, and WR3. When you build a system around MBX32E, you select a chamber. A chamber like MBX32 gives you a far field distances from 60 centimeter and all the way to 90 centimeter. And that's usually quite enough. And you have instrument bays underneath where you can locate your instruments. And after that, you have the Gimbal 4 300E, which is a Gimbal 4 300 variant that allows for the mounting of the extenders. And after that, you select the extender kit that goes with it. The extender kit could be, for example, if you want something for 77 gigahertz, right, then you will have the extender kit EXT12. EXT12 is the part number for the kit that comes with the MBX32E, where you would have the transmitter extender, the receiver extender, their power supplies, and all the wirings, such that you just have to connect to a VNA. The VNA that we need in that case is a VNA that supports 20 gigahertz of bandwidth. Most brands out there, they all have those kinds of VNA that can support 20 gigahertz. And so the kit comes with the RX and the TX extenders separately, the 5 coax that are SMAs or 3.5 millimeter coax for routing the signals, the power supply and the controller and the software for the positioner, and all this is fully integrated. All right, so let's take a peek on the inside. Inside, of course, a key element is the absorber. The absorber that we have is performing very well in sub-THz frequencies. For one, it's convoluted and not pyramidal, and that's something that we like for those kind of frequencies, and especially it's non-painted. We don't. We like blue, we like orange, but we don't like paint on our absorber for those frequency. So it's still performing at 50 dB attenuation all the way in sub-THz. The second element is the 3D positioner. We have a lot of videos about those. This is a gimbal 4300E, as we discussed earlier, with azimuth and elevation control down to 0.1 degree of resolution, and the laser alignment feature. And now we have that 300E deck, which is a little bit unusual compared to just a flat DUT mount. Here we have the extender from AirAvent and a little stub, and the WR6 that we're in D-band today. So this is our WR6 standard gain horn, 20 dBi. So I wanted to show you this view where we see clearly from the back. So we clearly see how the wire routing is done. It goes from here. You have two coax go on this side, one coax and the power supply go on this side, and then they loop back through the arms and then down the shaft of the gimbal, and they arrive at the VNA on this side. On the probe side, we have the other side of the frequency extender. So in our case, that's our RX. We have a mount, a fixed mount, which allows us to place the extender in 90-degree polarization. So you can mount it this way, you can mount it vertically, and you have laser target adjusted to make it the alignment with the transmitter. Here we have a block of absorber that's to limit the standing wave surface of the extender. And we have our reference probe. Here we have a 20 dBi WR6. Also in the back, we have a number of coax to run. We have LO and RF and a power supply. So those are the three feed. There is a debate, about whether you should put the RX on this side and the TX on this side, or vice versa. Given that in our case we're doing S21 or S12, should be about the same, but that's your choice. Also, as an option, AirAvent provides us with a calibration kit for this frequency. For example, in our case, we'll have a WR6 calibration kit, specially made for those extenders. So this is the extender, the receiver module from AirAvent. This is the WR6 that we were looking at before. We like to have a 1-inch extender, waveguide here, and then we have our 20 dBi WR6 probe. And in the back, we have those two coax, SMAs or 3.5 millimeter in measurement, or LO, on-off switch, and the power supply. So that's all there is, very compact 3D measurement. A lot of measurement is just like linear, on rails and guides and things like this. But this is, with MBX32E, you can really push it like, okay, now, can you do 3D radiation pattern over the air at 330 gigahertz? Now we can. So we're not going to do a demo with the software and everything with that setup. That video already exists on YouTube, and you can check it out for all the details on the control and software side. So check it out on our YouTube channel. So this is it for today. I hope you liked it. If you have any question, don't hesitate to contact me. Otherwise, talk to you later.